In this video, we're going to look at the relationship of inheritance. I would just want to remind everybody that this particular material is really useful to know before you take the next class in the computer science programming sequence, Computer Science 240. And this information will be reviewed when you take 240, but if you've seen it once, it really gives you kind of a head start when you take that next course. This information, however, will not be on the final exam for Computer Science 220. So we're talking today about the inheritance relationship, and that's a relationship that can exist between two classes in a Java program. And so we're going to be thinking about when you would use this relationship, and hopefully when we do the example, you'll see why you would want to use this because it saves you a lot of work. So you use inheritance in a project if you already have a basic class that you've created and tested, and now you realize there's a more kind of specialized version of that class that sometimes you would want to use in your project. And your more specialized version of the class, if it has all the same data and all the same methods as the original basic class, plus some additional methods or data, then the inheritance relationship can be leveraged to save yourself a lot of work because it allows you to create the new, more specialized class with minimum effort. So the development will go much more quickly than if you started from scratch to create that new data type. And again, the key here is that you have to already have an original class that has data and methods in it, and then your new class that you're trying to create has to be a more specialized version of that. If that relationship exists, then inheritance is going to really help you out. So let's look at an example of when we might want to use this in a program. Suppose that we are writing a project and it involves keeping track of some students at UMW. And suppose that we've already written a student class that stores and manages information about a single student. And let's pretend like the student class stores their first name, their last name, their GPA, and the credits earned. And that we've already implemented some constructors, getter and setter methods, a toString method, and an equals method for our student class. And we're in exactly that situation. A couple weeks ago, or last week maybe, no, it was like 2 weeks ago, maybe 3 weeks ago, we created a student class, and it stored information about the student's first name, last name, GPA, and credits. And we went through how to implement the various constructors for that class. We also wrote a series of setter methods for the class. And we also wrote a series of getter methods for that class. We could also write a toString method and an equals method. Looks like maybe I don't have those in this particular version of the code. I'll add them in there before we do the next segment of the video. So pretend like we already have this class implemented, and now we realize in our project we don't want to just store information about students. Sometimes we want to track information about resident students, people who live on campus. And we do some investigation about what information would need to be associated with resident students in our project, and we discover resident students also have first names, last names, GPAs, and credits earned. And in addition, we also want to store information about their dorm name and the room number where they live. And suppose that in our analysis, we identify the fact that the resident student class should have methods that are really similar to the student class's methods. The resident student class should contain constructors, setter methods, getter methods, a toString, and an equals method. So you might ask yourself, could we start from scratch and create a resident student class? Sure, we could do that. You could go into IntelliJ and you could say, I want to make a new class file, and you could just start from scratch and design a resident student class. And that would be perfectly legitimate and fine. But we could also leverage this idea of inheritance to work smarter, not harder. By using inheritance, it will allow us to inherit all of the data and all of the methods that were part of the basic student class. And inheritance will also allow us the flexibility of adding on additional data and methods that would be needed for our new custom data type, the resident student. So again, we already have the student class implemented, and that's one of the keys to inheritance. If you were writing a project and you realized, hey, I need to store information about resident students, and they have first names, last names, GPA, credits earned, dorm, and dorm room number, and you didn't already have a student class, you would probably just create the resident student class. You wouldn't bother to separate out the student type and the resident student type, because your project maybe just uses the resident student type. On the other hand, if you've been writing projects and they're all kind of related to each other, and you've already created some projects that use a basic student data type, and now you're adding on features or writing a completely separate project and realize that you want to create this resident student type that's really similar to the student type you've created in the past, that's when inheritance is going to come into play. So let's look at the syntax needed for defining an inheritance relationship, because we've identified the fact that our resident student data type is just a more specialized version of the student data type. So we're going to be able to leverage inheritance in order to create the resident student data type. Whenever we're creating a inheritance relationship, we talk about there being a subclass and a superclass. The superclass is the original basic data type, the thing that you've already created. And then we want to define a new subclass, the more specialized version of that original data type. And to do that, we have to indicate that the subclass inherits from a specific student class, superclass, and we do that using the reserved word extends. So we know that in our program, we're going to have a student data type and a resident student data type. The student type is the original class. That's going to be the superclass. The resident student data type, that's the subclass. It's the more specialized version of student. And so when we define the resident student data type in our class file, we're going to use this syntax to show that the resident student data type inherits from the student data type. And the keyword or reserved word in Java that means inheritance is extends. So we say public class resident student extends student. And that's the flag that tells the compiler I'm using inheritance. Now, whenever you're using inheritance to define a subclass, you only have to declare the differences between the two classes. You don't have to duplicate any of the data declarations or method declarations that were part of the original class. So if you think about it, we talked about what kind of information would be part of resident student. It's going to store the student's first name, last name, GPA, credits earned, dorm, and room number. Let's look back at the original student class. See that it also has 4 of those pieces of data in it: first name, last name, GPA, and credits. And so there's no need to duplicate that information as we define the resident student class. Instead, we only need to focus on the new information, the data that wasn't part of the basic class. And that information is the dorm name and the room number. So if we're defining our new data type, I'm going to make a new class file in IntelliJ. And I'm going to call it resident student. And I'm going to say that it extends student type, my original class name that I have. And then I'm going to define my data fields for the resident student. And again, I'm going to get those fields that are part of the student class automatically. I don't need to reduplicate that information here. Instead, I'm just going to include the information that's new and specific just to resident students. And that is the dorm name and also the room number. For the room number, you can decide how you want to store it. Maybe the room numbers only have numeric values, in which case you could store it as an integer, or maybe it's a complex building like Trinkle Hall, and some of the rooms have a B in front of them for the basement, and so you want to store the room number that way. That's your call. I'm going to store it as a string. But again, if you wanted to pick an integer, that's not wrong. So our definition for the student class would look something like this. Again, your call whether you might want to make the room number an integer or a string. In your notes, it asks you to draw a picture of what a resident student would look like. So in other words, if we were instantiating that resident student class, using syntax like this, asking you to draw a picture of what kind of data members, what kind of data fields would be associated with that object, a student. I'm going to make a little table to show the information. So my object is going to store information about the data fields that are part of the student class. So every time I make a new object of type resident student, it's going to have a first name field, a last name field, a GPA field, and a credits field. And then it's also going to have data fields for my two additional types, dorm and room number. And then, of course, it'll store the actual data value that is used to initialize or change the value of all of those different data fields. Right now, if we're just using a default constructor, there's probably a lot of blanks in there. But you get the idea. The idea here, the important thing to know is that you get space to store all of that information associated with a student data type, and also space to store the information associated just with the resident student data type. Because all of that information together defines a resident student.